Welcome back to the Digital Fluency video series, The Story of Data. As always, for maximum benefit, we suggest watching this video in full screen. We'll continue with our discussion of databases. There are three types of relationships between tables, and when we draw database diagrams, we use the lines with arrows to indicate the type of relationship we're talking about. There are the one-to-many, many-to-many, and the one-to-one relationships. The side with no arrow means that the value in that key column is unique. The side with an arrow means that there can be many rows in that table with the same value in its corresponding column. The most frequent relationship between two tables is the one-to-many. In this example, each payments row contains a unique payment ID. All of the payment rows with the same customer ID belong to the same customer. Each customer row contains a unique customer ID. Our SSNs are that way, aren't they? All of the order rows with the same customer ID belong to the same customer. Each order row contains a unique order number. All of the line item rows with the same order number relates to the same order row. Each line item row with the same product ID relates to the same product row. Each products row contains a unique product ID which relates to the many rows from the line items table. In a many-to-many relationship between tables, for every one row in table A, there can be many related rows in table B. The reverse is also true, which means that for every one row in table B, there can be many related rows in table A. That's why we show the relationship with arrowheads at each end of the line. Let's look at an example. A car rental company certainly keeps track of their car inventory, so we would have a table that contains data about their cars. They also keep track of their customers, so we would have a table that contains data about their customers. Every car could have been rented to multiple customers, so there exists a one-to-many relationship between cars and customers. However, each customer could have rented multiple cars, so there is also a one-to-many relationship between customers and cars. And voila, we have a many-to-many relationship between the two tables. By the way, a chart or diagram showing tables and their relationships is referred to as an entity relationship chart, or ER chart. We often use these charts as tools on whiteboards or in Visio diagrams to help us design databases. Now, some persons use different line endings, like multiple arrows, crossbars, and crow feet, but I like to keep mine simple. The end of the line either has an arrow or it doesn't. In a one-to-one relationship between tables, for every one row in table A, there can only be one related row in table B. The reverse is also true. For example, a business might decide to assign one office to exactly one employee. Thus, one employee can only have one office. A business might also decide that a department can have only one manager, and so an employee can only manage one department. In addition to relational, you've probably heard about some of the other classifications of databases. Some of the more common ones include centralized, cloud, commercial, distributed, NoSQL, open source, operational, and personal. Let me demystify those for you. A centralized database is one that is physically stored entirely within a single location, on a central computer or database system. Centralized databases are typically used by businesses, universities, or government organizations. Users can access the database through a local area computer network, but it is the central computer that runs and maintains the database. A cloud database is one that can be accessed over the internet. The data is stored in an on-premise data center or with a cloud service provider. In either case, the data is available online. This makes it easy to access your files from anywhere, as long as you have an internet connection. Access to the data is usually via encrypted communications, as all essential internet traffic should be. A commercial database refers to any database management system or database engine that you have to pay or license to use. When discussing commercial databases, you will probably hear names like IBM's DB2, Oracle, Microsoft's MS SQL, Informix, SAP, and others. A distributed database is one that is spread out over multiple devices. Rather than having all data stored on a single device, like a centralized database, distributed databases reside on multiple computers, either within the same location or across a network. The benefits of a distributed database include increased speed, better reliability, and ease of expansion. A NoSQL database has a hierarchy similar to a file folder system, and the data within it is unstructured or non-relational. You know, like imaging data, or machine-generated data, or audio and video data. This lack of structure allows them to process large amounts of data rapidly, and it is easily expanded should the need arise. Cloud computing often makes use of NoSQL databases. When discussing NoSQL databases, you will often hear the term Hadoop. To date, this is the most common database management software to power NoSQL databases. It is open source and was developed by the Apache Software Foundation. This software facilitates using a network of many computers to solve problems involving massive amounts of data and computation. It provides a framework for distributed storage and processing of big data. Hadoop is designed with a fundamental assumption that hardware failures are common occurrences and should be automatically handled. Oh, what's big data? Lots and lots and lots and lots of data. More academic is that big data is a discipline that treats ways to analyze, systematically extract information from, or otherwise deal with data sets that are too large or complex to be dealt with by traditional data processing application software. An open source database is designed for the public to use for free. Unlike commercial databases, users can download or sign up for open source databases without paying a fee. The term open source refers to a program in which users can see how it was written and constructed and are free to make their own changes to the program. Open source databases are typically much cheaper than commercial databases, but they can also lack some of the more advanced features found in commercial databases. Operational databases allow users to do more than simply view archived data. They are specifically designed to allow users and applications to insert and update data in real time. Operational databases are often relational databases because they usually process structured data. A personal database is one that is designed for a single person. It is typically stored on a personal computer and has a very simple design consisting of only a few tables. Personal databases are not typically suitable for complex operations, large amounts of data, or even business operations. The most common of these is Microsoft's Access database. There are other types of databases, but they are far less common. So how big can a database get? Well, the sky is the limit. Well, maybe not, but certainly your budget might limit what you can afford for electronic storage space. But I can tell you how we measure the size of a database. If we look at Bob Johnson's row in the customer table, we can see that the customer ID takes up 1 character or byte of data. The first name, 3 bytes. The last name, 7 bytes. And the date of birth, 8 bytes. Add that up, and we get a customer row with 19 bytes of data in it. One caveat is that not all customer rows will have the same number of bytes of data, as much of it can be longer or shorter. Like the first name. Many persons have names much longer than that. Address. There's another one, where the length varies like crazy. Another caveat is that 19 bytes of data is not realistic, since usually there are a lot more columns of data than just those 4 in a customer table. Anyway, for the sake of this example, let's say the average total number of bytes in a row is 1,000. With 100 customers, how large might the customer table be? Only 100,000 bytes. With 1,000, it grows to 1,000,000 bytes. With 1,000,000, it grows to a huge number of bytes. With 1 billion, it grows to an unbelievable number of bytes. And with 1 trillion, it grows to an unimaginable number of bytes. And that's just the customer table. There are other tables in the database. In fact, some databases have dozens, if not hundreds, of tables in them. So let's wind up this scene with a discussion of data sizing terminology. Kilobytes are mostly used to measure the size of small files. For example, a simple text document may contain 10 kilobytes of data, and therefore it would have a file size of 10 kilobytes. Graphics of small websites are often between 5 kilobytes and 100 kilobytes in size. Individual files typically take up a minimum of 4 kilobytes of disk space. Megabytes are mostly used to measure the size of large files. For example, a high-resolution JPEG image might range in size from 1 to 5 megabytes. A 3-minute song saved in a compressed version may be roughly 3 megabytes in size, and the uncompressed version may take up to 30 megabytes of disk space. Compact disk's capacity is measured in megabytes, approximately 700 to 800 megabytes, whereas the capacity of most other forms of media drives, such as hard drives and flash drives, is generally measured in gigabytes or terabytes. Gigabytes are sometimes also abbreviated as gigs and are often used to measure a storage device's capacity. As an example, a standard DVD drive can hold 4.7 gigabytes of data. Storage devices that hold 1,000 gigabytes of data or more are measured in terabytes. Mostly, the storage capacity of large storage devices is measured in terabytes. Around 2007, consumer hard drives reached a capacity of 1 terabyte. So now, hard disk drives, or HDDs, are measured in terabytes. A typical internal HDD may hold 2 terabytes of data, whereas some servers and high-end workstations that contain multiple hard drives may even have a total storage capacity of over 10 terabytes. Most of the storage devices can hold a maximum of a few terabytes. Therefore, petabytes are rarely used to measure storage capacity of a single device. Instead, petabytes are used to measure the total data stored in large networks or server farms. For example, internet giants like Google and Facebook store more than over 100 petabytes of data on their data servers. The exabyte unit of storage measurement is so large that it is not used to measure the capacity of storage devices. Even the storage capacity of the biggest cloud storage centers is measured in petabytes, which is a fraction of an exabyte. Instead, exabytes measure the amount of data over multiple data storage networks, or the amount of data that is being transferred over the internet for a certain amount of time. For example, several hundred exabytes of data are transferred over the internet every year. 1 zettabyte contains 1 billion terabytes, or 1 sextillion bytes, which means it will take 1 billion 1 terabyte hard drives to store 1 zettabyte of data. Generally, zettabyte is used to measure the large amounts of data in all of the world, and that is just a few zettabytes. 1 yottabyte contains 1 septillion bytes, which are exactly the same as 1 trillion terabytes. There is no practical use of such a large measurement unit because, as I said before, all the data in the world is just a few zettabytes. I think it's time for an intermission. I recommend that you get up and stretch, take a walk, take a bio break, get a snack and a beverage, take a nap. When you're ready to come back, please fire up the next video in this series. I promise to wait patiently, no matter how long you take. See you later.